Hello everyone, welcome back to SDN Bits, and in today's video we are going to explore PYEAPI library for Arista EOS automation. As you can see on my screen, I have exactly the same lab environment from the previous lab, and I have enabled only 3 devices in this lab due to my incapable laptop hardware. So I have enabled just Spine 2, Leaf 3, and Leaf 4, which were the devices we were actually working on the previous video, where we were configuring layer 3 Leaf and Spine topology. So now, in order to explore PyEAPI library, we'll go to the best place to find the most reliable information, and this is obviously the documentation. So this is the link documentation, which will be inserted to the description of this video, so you can easily access it. And if you open this link, you will see this page where there is a quick introduction of Python eAPI client, which is PyEAPI. So if you just read, it is a native Python library wrapper around Arista EOS eAPI. It provides a set of Python language bindings for configuring Arista EOS nodes. The Python library can be used to communicate with EOS either locally, on box, or remotely, off box. So in this video, I will use it on box first, and then again, I will use one of these devices, let's say Spine 2, to run and execute my Python scripts, and also obviously to store them. So I will basically use the bash shell of this Spine 2 device to accommodate my scripts and to run them. However, because it would be inconvenient to use Nano text editor to just construct scripts, I will use my Visual Studio Code application on my local workstation, and then I will just copy and paste the code to the Spine device and run it from there. That is simple as that. I really don't want a lot of overhead. Obviously, this server could be my automation controller. I could store and execute all my scripts here. I could make an external connection to my Windows machine, like I did in this part of the lab, as you can see, and I could execute my scripts from my Windows machine, and it could be sent to entire infrastructure. But just for the sake of simplicity, we will begin with Spine 2 as an automation controller. So this is the introduction page. Then you will go to the installation page. In the installation page, you will see basically the steps on how to install or upgrade PyEAPI. Very simple, just pip install PyEAPI as any other Python package. In our case, if you go to Spine 2 device, right? So default username and password is Arista. From the previous video, you should remember. If you go to the bash shell, and if you check, first of all, let's check if there is Python, just to make sure. There is Python and Python 3 as well. Yes, there is Python 3. We'll use Python 3 for script execution. And let's see if there is pip already installed as well, which is a package manager for Python. There is already pip. And let's see if there is PyEAPI already installed. So to do this, I will just run pip3 freeze command, and I will grep PyEAPI. As you can see, PyEAPI has already been installed on the bash shell of Linux of Arista EOS device already, which is extremely convenient. You don't have to go through entire installation process, because you already have all the necessary scripts. That is very, very convenient. So I will just skip this installation phase because we don't need it now. It's very simple, and I will go directly to Quick Start. So in Quick Start, we have this little section which says in order to use PyEAPI, the EOS command API must be enabled using configuration modes. This library supports eAPI calls over both HTTP, HTTPS, and Unix domain sockets. Once the command API is enabled on the destination node, create a configuration file with the node properties. There are some nuances about the config file that are important to understand. Okay, first we have to enable eAPI on our devices to be able to use PyEAPI. I will go ahead to each one of my devices, Spine 2, Leaf 3, and Leaf 4, and enable eAPI on the CLI. So let's start with Spine 2. I will go back to the CLI. I will drop down to configuration mode, and here I will run this command: management, API, HTTP commands, and under this section I will basically run no shutdown command to enable it. But before running it, let's just see how it looks like by default. So show management, API, HTTP commands, and as you can see, HTTPS server is enabled. However, there is nothing about the API itself. So if we run the no shutdown command right here, and if I run this operational command again, I will see that now I have multiple links to the management interface of this API, of the GUI. So I can use any of them to connect to it. Let's presume in our case it can be this one, the loopback interface. So I will just copy this link and I will try to open it here. I might have some routing issues with it, but let's see. So yeah, that's right. I should not be able to do it right now because there are some routing issues. But this is not important as of now anyways. So let's just go ahead and use PYEAPI. Yeah, I need like internet connection to be able to ping this address from my workstation, so that is why we're unable to do it. But that's not a big deal anyway. So now we're opening up the spine 2 and we can see that we have already enabled PYEAPI here. So let's go ahead and do it for lift 3 as well. So if you go to lift 3, inputting default credentials, enable, conf. Let's check the status here as well. API, HTTP commands. As you can see, there is no eAPI activation. So I will just go ahead, management, API, HTTP commands, and issue no shutdown command, right? And I will run this command again, and now there you go. So enabled, yes, this is the part you should pay attention to. As you can see, before it was not enabled, and now it is enabled. And we will do the same thing for our last device, last enabled device. Arista, enable, configure, management, API, HTTP commands, no shutdown. Simple as that, right? Now we have enabled eAPI on our devices. So we have completed this step, and by default it will use HTTPS, because HTTPS server is enabled by default, to be able to connect and issue any commands on our devices. Now this step is completed. The second step is to create a configuration file with node properties. Now, if you go to this link, PyAPI configuration file, here you will find all the instructions on how to create this file, right? So basically, this file is a simple inventory. It is a simple inventory where you will store your device information, and using this conf file you can access basically everything quickly, and this file will become your source of truth, the unique source of truth, right? And let's just go ahead and create this file directly on the switch. So I will open up the spine 2 device, and I will again drop to the bash shell. Now, the place where the directory where you should create it's very important. If you scroll down here, you will see that, no, in this file, okay, you will see that where should the file be placed. So where should it be placed? And you have the environment variable option, which you have to do anyway because you must access it. And you can store it in the home directory as a hidden file, as you can see, or you can store it in the flash directory. Now we'll store it on the flash directory because after rebooting the device, the contents of this directory will not be erased, which is not true for the home directory. So just to make sure it's persistently there, I will open up this directory and I will create this file right there. So let's just do it now. I will go to the flash directory, so mnt flash, and as you can see here I have a bunch of files like the ZTP file from the first video if you remember, and here let's create an eAPI.conf file. Good. Now when it comes to contents, if you scroll down you must see this particular section where we have a quick example on how to construct this simple conf file for HTTP or HTTPS connection. So I will basically copy one of them. I mean, you could copy that, but okay, let's do it anyways. I will copy it and I will put it here, and I will change it accordingly. Now, you could have this particular section for each of your devices. However, to make it even easier and more readable, there is this default section. The default section can be used to gather globally applicable settings. Say that all of your nodes use the same transport or username, you can do something like this. As you can see, this is more convenient because all of my devices have these credentials, username Arista, password Arista, and the transport will be HTTPS for all of them anyways. So I will go ahead and I will just do exactly this for much more efficient text file. Let's put it this way, the conf file. So I will just get rid of this, and I will paste this one, and now I will just indicate my connections. So the first one will be spine 2. You are just putting hostname here. I will change my default credentials to transport is HTTPS, so we're not touching that. And the IP address. I will use the loopback IP address to connect to our devices. So the loopback IP address for leaf device is 0.5 for leaf 3, and for leaf 4 it should be 0.6. Just to verify, I'm going to run this command here, show interface loopback 0.6, and for spine is 0.2. So 0.2. Now I have to copy it and change the host name to leaf 3, and the same goes here. I will change it to leaf 4. The IP address here will be 5, and the IP address here will be 6, right? So that should be it. This is our eAPI.conf file. As you can see, I have indicated all of our 3 enabled devices with their loopback addresses and their host names, and the default settings for all of them, which is credentials and the transport method. I will save this file and quit. So now we can see that this file has been saved right here. Good. Now we can proceed with the other steps. We already created the eAPI conf file, and now we can go ahead and connect to a node. The Python client for eAPI was designed to be easy to use and implement for writing tools and applications that interface with the Arista EOS management. Now this is very important as well, because if you have watched our our second video of this playlist, you would see that we were having some kind of, let's say, clutter or abstractions, lack of abstractions with the JSON RPC libraries and other kind of on-box connection methods, because we would have to be more specific to indicate what we want. But PYEAPI library facilitates this for us by abstracting all these low-level, let's say, functions and wrapping them under simple methods which we can just call and use, right? So let's go ahead and construct our first PyEAPI script. But before that, I have forgotten to complete one more step from the PyEAPI configuration file, and this step is obviously making sure that we can see this eAPI conf file. So our script must see the eAPI conf file and retrieve the device settings from that file. And in order to do this with eAPI.conf file, we have to create an environment variable which points to it, right? So in this section, if you just go up, you will see that we must create this environment variable. So I will go ahead to my spine 2, and because it's a CentOS device, essentially, right? It's a CentOS device. I will just create an environment variable as I would do for any CentOS device. And so first of all, we will have to go to sudo nano dot bash crc file, obviously. And in this file, we should be able to just, let me check one simple thing. The bash rc, sorry, bash rc file. Yeah, and in this file, we just have to indicate the user-specific OS function. So yeah, the environment variable itself. So it will be export eAPI conf, and we have to specify the path to our eAPI conf file, which is mnt flash, sorry for that, mnt flash eapi.conf. And now we have to save this file, and we have to source this bash rc file. So bash rc, and that's pretty much it. So now we should be able to retrieve settings from this eapi.conf file. Right, so now let's create a folder, let's say, where we can store our scripts in this mnt flash directory. So I will create a folder called, let's say, scripts, or how else we could say it, let's say PYEAPI scripts. Right, and I will enter to this directory. Good. And in this directory, we can actually create and construct and store our scripts. So let's go ahead and create our first script. I will call it, let's say, nano test.py, right? Yeah. Obviously, the first thing you have to do is to make sure there is shebang. I mean, you can skip that, but if you want to execute your scripts without indicating Python 3 all the time, you can just go ahead and create a shebang line. So I will go ahead and just do that. In our case, it's going to be user bin Python 3. I do not run any virtual environments because it's an Arista device. I don't really see the point of doing it on Arista device itself. And besides, it's just demonstration. It's not really how you should do things in production networks, obviously. And let's put a small description, which is the doc string. So testing various PyEAPI methods, I don't know, functions, let's say, and let's close the doc string. And now we can go ahead and open up this file and just start understanding what we should do. Now, so we have imported the library, and the second step would be create a node object by specifying the node to work with. Right, so I will just copy this, or I will not copy, I will write to myself. So basically here we will use the connect to method to instantiate a node object from our eapi.conf file, right? So okay, so I will go ahead and open up my script. I will actually put it right here so I can see what's going on. So node PyEAPI.connect to, and I will specify the host name, which is, let's put leaf3, right? Let's put the, so if I put the other device, which means it will be off-box script execution because we're executing the script on the spine tool, which is not the leaf3, right? And it means it's off-box. And it means it has to use HTTPS as a transport method to connect to the leaf3 device. Now, this method, what it does exactly, again, we're creating a variable called node. It can be anything, device, node, whatever, host, as you wish. Then we are using the connect to method of PyEAPI library, and we are specifying exact host name from our eapi.conf file, right? As you may recall, in our eapi.conf file, we have the spine to leaf 3 and leaf 4 separately indicated, and we're picking just leaf 3. Good. So let me actually also put the comments so we can professionally navigate and document our script by specifying the node to work with. Right, good. And then we're going to send commands to the node. That's our second. Now, the first function they have indicated here, the first method, is enable method. If you run node enable, and in the parentheses, you have to indicate the string of the command you would want to run. In this case, we have the show hostname command. Let's put different command. Let's say show version. Right? Show version command. Good. This function will do it, and let's store the output in a different variable. Let's actually do it like this. Output is this, meaning the output of show version command. So go to the enable mode pro and issue this command and store the output here. And now let's just go ahead and print the output. And let's see how it goes. Print output, right? Simple script. We are instantiating a node object, meaning we're connecting to one of our nodes in our inventory. And then we are sending show version commands, and we're storing the output, and then we are printing it out. So if I save it and quit, in theory, it should work. Before doing this, let me go ahead. Now, I could use Python 3. I could say Python 3, and then I could put the script's name to execute this. It will work perfectly. But just to make things more professional, I will go ahead and I will turn this test.py file to an executable file, so I can just execute it without explicitly specifying Python. Now I will go ahead and say chmod 777, meaning for executable file conversion, and I will specify the file name. Now if you run this command again, you will see that now we have turned this file to an executable. And now if I just run it as any executable in Linux, it should work. So if I do it, name PYEAPI is not defined. Interesting, it's not defined. Name PYEAPI is not defined. Now let's see. Line 7, it's not defined. What do you mean, we haven't imported it? Let's check the file. Yes, of course, I have made a stupid mistake by completely forgetting about importing PYEAPI, obviously. Obviously, that is my mistake. So let me just put a comment here, import libraries, and the first library we need is PYEAPI. Well, it happens, I guess. And now I should be able to execute. Yes, perfect. Now, after running the script, we can see the output in a JSON encoding, in a JSON format of show version command. And as you can see, this output is a little bit inconvenient, uncomfortable to read. So let's use prettyprint function and to make it more readable. So I will go back to my script. I will import prettyprint from prettyprint. I'm not sure if we have it here on our bash shell, but something tells me we should have it because it's a very basic thing to have. So let's now use this prettyprint function to have indentation and easier readability. So I will just go ahead and run this script again. Yes, that is much readable. Now, as you can see, the output we have is again in the JSON format, right? JSON format is a structured data format, which is amazing because it is extremely easy to manipulate this type of data. You can specify the keys and you will get the corresponding values. And since we want to know the version of our device, I will go ahead and I will specify the part where they indicate just version, which is obviously this part. So I will go ahead and I will extract only this value. To do this, as you may recall from the JSON, from the dictionary Python objects or from any JSON file, we have to specify the key. But to go to this key, we have to make sure to indicate all the keys in the hierarchy, meaning to understand the nested data structures. So if you can see, let's go to the very beginning of this output. I will just select this part. This is our entire output, and the first symbol here is this square bracket. And square bracket in Python means list. This is a list file, right? And there is only one element in the list file, which is just this huge dictionary, let's say, right? And to access anything in the list, you have to specify the index of the element. And because there's only one element in this list, right? There's only one element. You don't see anything else here. You don't see the comma and then another element. No, there's just one element. And first thing we have to do, obviously, is to go to our script and specify that we are working with the first element and the only element of the list. Then the second in our case, can you see the output? Yes, we can. Will be the dictionary element inside the list. Now, if you look at this dictionary element, it has multiple keys and values. So the command, which is a key, has a value of show version. This is the command we sent. Encoding has a value of JSON, and result has a value of another nested dictionary, right? Meaning, if you want to access the version which happens to be inside the result value, you first must specify the result key. I will go ahead and here I will specify the result as a string, obviously. Now, the last element to access the version would be the key, which is the version itself, because now we have already accessed the result. We will get this output only. And from here, all we have to do is just to pick the right key, which is the version key, and then indicate it right over here, right? So version, and that's it. Now, if I save this file and run it, I should get only this particular entry, this particular string given, nothing else. So let me just do it. Good, perfect. Just what we needed. Great. So now we have worked with the enable method. Let's go ahead and see what else we can do. We could request a specific revision of a command that has been updated, right? That is also the option which EOS PYEAPI library provides to us by specifying this option right here. This is convenient if you need specific type of output. So then we can use the config method to send configuration commands, right? Now, let's go ahead and try it. Let's open up our spine device again, because we have our script here. Let me actually go back to the test file. And let's send config commands. So config commands, right? We'll use the node object again, which is our leaf3 device in this case. And we'll use the config method, exactly the same as enabled in terms of syntax as this one. But instead of retrieving operational data from the device, we are going to push the config to the device. Let's see how it works. In this particular case, we can see that they are changing the host name of the device, but we will go ahead and we'll do something else. Let's say I want to change the description of one of our leaf devices, right? So leaf3, show interfaces descriptions. We can see that, for example, Ethernet 5 doesn't have any description, and if you look at topology, it is connected to the server too. So let me go ahead and create a description for our leaf3 device. So I will go back here and I will say so. And if you just look down here, multiple commands can be sent by using a list, right? So if you want to send one command, you can use this format. That's perfectly fine. You can just indicate a string. However, if you want to send multiple commands to the device, you should use a list. And it works for both enable methods and config methods. Now I will go ahead and I will do just that. I will create a list where I will store this command strings. The first will be interface Ethernet 5, and then comma. The other string element would be description. Let's say link to server 2 and closing. So good. Now this should work. I will and to verify this, obviously we will find it out by using an enable command to, so I will just go ahead and to verify, I will run show interface description command. So not enable, show interfaces description, show interface description, right? So this is the entry which we will have to modify. And let me just run description. Good. Show interfaces description. Okay, so, and this will return a JSON output. Now let's just see how it looks like. So if you want to see in advance how your output would look like with JSON, you can just go to CLI. Thanks to Arista EOS for providing this feature. Basically, just the command itself, and then hit the pipe. And if you hit the question mark, you will see the JSON option here, which produces JSON output for this command. Now that is what I will do, JSON. So this is what you will get. And again, this might not be the most readable format. And since we just need the Ethernet 5 and description, I will just go ahead and I will see how could we. So this is a JSON file. It's not a list. Interface descriptions. This key consists of these values. So first, obviously, we will have to get interface descriptions. Let me open up the spine too. Interfaces descriptions, and I will store it in, let's say, description output, and I will print the description, and I will specify what exactly has to be specified. Interface descriptions, Ethernet 5, paste that over here, and lastly the description, obviously. Good. So this should return me this part instantly, and let's just go ahead and check it. Now, should we wait until the command? So I'm wondering if we need to wait after pushing the config for a bit and then retrieving the output. But we'll see. If we don't get an output, we'll just rerun the script. And in this case, yeah, in this case, nothing else is important. I will just add some indicative strings to make it more readable. So we could say version, right? And here we could say description, just to make it much more readable as an output. So let's run it and see what's going to happen on our device. So yeah, where is our spine? Good. Okay, great. Now run the script. Attribute error. String object has no attribute right. Which right object are we talking about precisely? So let me see the script again. I'm not really sure what. Let's first check the leaf device to see if configuration has been actually pushed. So if we run this command, I can see it's not pushed. Okay, okay, good. It means our problem resides, our problem must reside somewhere here. I will try to see. So maybe I have made a mistake. Interface Ethernet 5. Description link to server 2. That should not be a difficult command to execute. Let's open this up, and I will just try to, for now, comment this part to troubleshoot better. Again, we are just, I think it happened here. Something that I've done here might have. Interestingly, let me just, yes, run it again. Line 15. Yeah, it's here. So what is it exactly? Line 15, which is this one. Some stupid mistake, probably I'm making it, I cannot see it. It was Python syntax. So a string, what was the error? This str object has no attribute right. It doesn't have to have an attribute right. I don't really understand what it means by that. Okay, let's just get rid of this, right? And get rid of this as well. Just show me how it works. Let's put it this way. Control X, save yes, clear, and run it. Now, okay, so now we can retrieve the version better. Okay, so what else? Type error, list indices must be integers or slices, not string. Okay, so this is, so if error happens on the very last entry, it means config must have been pushed. Let's go to the leaf device and to check. Yes, if you can see, our description has been successfully modified. There you go. However, the output has some problems, so let's go ahead and solve the output issue. What is your problem with the output? Now, just okay, just return me the description component, and let's see what do you return. Control X, yes, clear. Let me just run it in a bigger screen. Okay, so that's a huge output. Okay, there you go. Yeah, I forgot about. So from the CLI you can see only this part of the JSON output, but from the PYEAPI perspective, or eAPI perspective in general, you have all these keys prior, which means you must indicate them every single time, right? Good. So, okay, let's go ahead and do the same thing as we did before. This is nothing strange, really. So we'll have the list elements 0, then we'll have result key, which consists what we actually need, right? And that would be interface descriptions. This should consist, just contain Ethernet 5. And this should contain description. So let me just go up and verify. The list 0, result, interface descriptions, Ethernet 5, description. Let's save it. Yes, and run it. Perfect. Now we just retrieve the description string that we were needed. Okay, so perfect. Good. We have sent an operational command to our device to retrieve operational data, to gather the version data. We used the config method to push configuration to the device by modifying the description of one of our interfaces. And in the last part in this quick start file is returning the running or startup configuration from the node, right? So if you use running config method or startup config method, you will basically retrieve the running or startup configuration. So let's go ahead and try this as well. I will use the same script. I will actually open it here. Nano test py, and let's say retrieve running config and startup config, right? Good. So it will be print. We can actually say, let's say running config. Let's say run config like this. This is a variable which will store the output, and basically it will be node, which is our leaf3 device in this case, and we will use the running config method, and let's just print the running config, see how it looks like. That should be it. Control X, yes. So just to verify, underscore. Did I put underscore or a dash? I put a dash, which is a stupid mistake. Let's just go and change it real quick. Obviously, it's an underscore. From the syntax perspective, it makes sense. Clear the screen and run the script. There you go. So this huge output is basically the running configuration of the device, but it's very, very specific because here we can see that it shows even the negations of commands which are usually not visible by default. And let's go ahead and see how the startup config output looks like. Should have been shorter, be shorter, sorry. Startup, I will just change this to startup. Okay, let's just put it here and let's just comment it out. And the same thing almost goes here. Uncomment, change this to str startup, and there you go. Startup, Control X, yes, clear, execute the script. Good. Now this looks much better. I mean, in terms of brevity, because startup config shows us only the necessary output that we need, as you can see. Good. Very, very good. So I think this is enough for now. In this video we have, to conclude, in this video we have gone through the PYEAPI official documentation. I have shown you where you can see the installation guide and how to actually enable eAPI on the devices by issuing the management API HTTP commands, no shutdown commands, and then we have created an eAPI.conf file, which is extremely important to have a source of truths and a simple inventory. Then we have created the path variables to use it as our source of truths, and then we connect it to our node, leaf3 in this case. It can be any node. You just have to specify it right here after the connect to method. And then we have used enable method to send operational shell commands and retrieve their output and to manipulate data in this output. And we have used the config method to push configurations, to send configurations to devices from our PyAPI script. And at the end, we took a look at the running and startup config retrieval from the devices in our lab. So I think this is enough for now. I don't really want to make video any longer. This is one of my biggest problems. I cannot really end up making brief videos. So stay tuned. In the next video, we'll keep on exploring this documentation file, which is very short file, which is very short documentation anyways, and then we'll use our own let's say, imagination and creativity to construct much advanced Python scripts and to work with multiple devices, not just one device, but multiple devices in our lab environment. And yeah, just make sure to follow, to subscribe to our channel, and in the next videos we'll have more fun and entertainment. I can guarantee you that. Thank you very much for watching. Please comment below if you have any questions or any objections. I would love to actually hear them out and respond. Thank you very much again, and see you in the next videos.